All right, today we're going to talk about something that doesn't just tweak the rules of propulsion, it completely tears up the playbook and throws it out the window. So here's the big, mind-bending question from our source material. Forget everything you know about rockets pushing against exhaust. What if an engine could actually pull on the very fabric of space itself? What if it could treat the universe not as an empty space to cross, but as something to be grabbed and manipulated? And that crazy idea gives birth to something called an inertial traction engine. The concept is wild. A vehicle that doesn't travel through space, but instead reels its destination in, almost like a fishing line. But, and this is really the important part, the vehicle itself, that's not the main event here.
No, the real story, the true focus of what we're breaking down today, is the thing that makes it all possible. We've got to look under the hood, at the revolutionary power source beating at its heart.
So just think of the vehicle as a cool application, right? It's a showcase. The real marvel, the piece of physics and engineering we're digging into, is the energy core. This is a power plant that completely changes the game.
Okay, so how on earth does this thing even work? Let's get into the nitty-gritty, the actual physical anatomy of this incredible power source, piece by piece.
Right at the heart of it all is the mercury core. And the concept is actually, beautifully simple. You use super high frequency magnetic fields to basically zap liquid mercury until it erupts into this insanely hot, brilliantly glowing plasma. The mercury isn't the fuel here. Think of it as the medium, the stage where the magic happens.
So let's look at the actual parts. You've got the mercury, and it's held inside the special structural mesh of titanium and copper that helps with the whole magnetic induction thing. Then you have these specialized lenses. They're called vitroceramic projectors, and their job is to aim the energy. And maybe most importantly, the whole shebang is encased in a perfect vacuum.
And you can't overlook that vacuum. It's absolutely critical. It's not just empty space, you see. It's the perfect thermos, the ultimate insulator. It separates that super hot plasma from everything else, which means no heat can transfer through conduction or convection. Honestly, that's the engineering sleight of hand that keeps the whole device from melting into a puddle.
All right, so we've got the hardware. Now for the process. How do all these bits and pieces actually come together to generate and, shape that energy?
It's basically a four-step dance. First up, induction. You've got these massive electromagnets creating huge, swirling currents in the mercury. Step 2, incandescence. The mercury's natural resistance to these currents generates an unbelievable amount of heat, turning it into a plasma that shines, brighter than a star. Third, and this is so key, condensation. All that light isn't just wasted. The core's own internal geometry captures and focuses it. And finally, projection. The energy shoots out, but not like an explosion. It's a hyper-focused, super stable beam of light, almost like a dart. And we're not talking about just a simple flashlight beam here. By projecting multiple beams in a very specific geometric pattern, they combine to create this stable, rotating structure of pure energy, a light vortex. This is the thing that supposedly has the power to interact directly with the fabric of space-time.
And this is where we get to a pretty mind-blowing quote from the source material. This vortex essentially creates a tunnel, right? A waveguide through space-time. So the vehicle isn't flying in the traditional sense. It's more like a particle being guided by this very structure it's creating itself. I mean, that just brilliantly illustrates the scale of the physics we're talking about here.
Okay, so we've covered the how, but what about the how much? Let's put some numbers on this. What kind of power are we actually talking about with this compact core? And trust me, the numbers are just staggering. First off, let's just talk potential. The core is capable of generating an electromotive force of 2.5 gigavolts. That's 2.5 billion volts. We're not just talking about electricity anymore. That's a field potential so intense it could, in theory, stress the vacuum of space itself.
So, what does that mean for continuous power output? Well, in a unit that's just 80 centimeters wide, that's less than 3 feet, the combined processes generate over 100 megawatts. The bulk of that comes from induction, but get this, it also harvests power from the plasma's light, from the insane temperature difference, that's the Seebeck effect, and even from its own feedback loop. Literally, nothing goes to waste.
So to put that into perspective, what is 100 megawatts, really? Well, it's about the same output as a medium-sized conventional power plant. But here's the kicker. While that power plant takes up several city blocks, this energy core, it fits in the trunk of a car. The energy density is it's almost hard to wrap your head around.
Okay, the raw power is one thing, but what this theoretical technology really implies, well, it's a genuine paradigm shift in how we even think about moving from one place to another, about distance itself.
And this brings us right back to where we started. Your typical propulsion is all about action-reaction, right? Pushing an object through a pre-existing space. This technology doesn't play that game. It treats distance not as a barrier to overcome, but as a variable to be altered. It pulls, it compresses, it effectively erases the space between point A and point B.
The source material uses this really powerful analogy to put our current technology into perspective. It says we're like a civilization that has the blueprints for an ocean liner, but we're all still out here paddling around in wooden canoes. If a system like this is even remotely possible, then our chemical rockets and combustion engines, they're just canoes.
And so that leaves us with one final, provocative question. Does a technology like this remain theoretical because the laws of physics genuinely forbid it? Or is it simply that our engineering imagination hasn't yet caught up to what the physics might already allow? It's a question that really redefines the boundaries of what's possible.